Okay, so it was brought to my attention that I didn't go over this in one of the classes, and so I'm going to send this out to everybody as a review and or to just draw everybody's attention to it. It's pretty straightforward, but it's also pretty important and vital for the exam. Basically, we talked a lot about velocity versus time graphs, and apparently in fifth period I didn't actually derive any acceleration versus time graphs, so I want to go over that really quickly. Basically, if we have this velocity versus time graph, we know the definition of the instantaneous acceleration is it's the slope of the velocity versus time graph. And so you can tell from this velocity versus time graph we have a constant negative slope. And so if I wanted to draw a sketch of the acceleration versus time graph, it's going to have a constant negative value, right? And then if I gave you numbers that allowed you to determine that the slope of that velocity versus time graph was -2, we would know that that constant acceleration value was -2, right? So because acceleration is the slope of the velocity versus time graph, a constant negative slope on the velocity means a constant negative acceleration. Similarly, if we have this velocity versus time graph, you notice there's two different slopes, and so we're going to have two different accelerations. The first slope is positive. Now notice, I don't care that the velocity is negative. I'm looking at the slope when I'm worrying about the acceleration. So for the entire first part of this, we have a constant positive value, and then the slope becomes 0, and so the acceleration will drop down to 0. Once again, if I gave you numbers, if you were able to determine that the slope of that positive part was +3, then the acceleration graph is just going to remain a constant +3 until the slope on the velocity graph changes. When the slope on the velocity graph drops off to 0, that means the acceleration would then fall down to 0. So again, acceleration, or instantaneous acceleration, the acceleration right now is the slope of the velocity versus time graph. So we can make those acceleration graphs from those velocity graphs. And then finally, one more example. Here, we have a constant negative velocity. Well, since acceleration is, by definition, the rate that the velocity is changing, if the velocity is not changing, you would expect the acceleration to be 0. And it doesn't surprise us because, again, the velocity graph has a slope of 0, and therefore the acceleration should stay at a value of 0. So again, just to really emphasize this point, you can have a constant velocity that's not 0, and that means the acceleration is 0, or you can have a constantly changing, go back to this one, a constantly changing velocity, which means that the acceleration is constant. All right, so just don't confuse those terms. If you'll just always remember that acceleration is the slope of the velocity versus time graph, you should be fine.